Today we are simplifying rational expressions. To do so, we've got a number of different properties that we have to keep in mind. The first is the product of powers. So if I've got a base and I bring it to some power m, so a to the m, and I'm going to multiply that to the same base a to some other power n, so a to the m times a to the n. Well, what I can do is just simplify this to a single base, so a single a, and I'm going to bring that to a power of m plus n. So I'm going to add the exponents together. So I've got 5 to the 7th times 5 squared. This is 5 to the 9th because 7 plus 2 is 9. Similarly, if I can multiply and then add the powers together, well, I can divide and subtract the powers. So a to the m over a to the n, m divided by n here. Then I've got a to the m minus n. Let's go back to using numbers. 5 to the 7th over 5 to the 2nd. This is 5 to the 5th because 7 minus 2 is 5. Now, if I've got a to the m and I bring all of that, the whole thing, to the nth power, then this will simplify to a to the, multiply the powers, m times n. So 5 to the 7th, that whole thing, to the second power, is the same as 5 to the 14th, because 7 times 2. Power of a product and power of a quotient are similar, just like product of powers and quotient of powers. Here, if I've got a times b and this whole thing is brought to the m, then I can kind of distribute that exponent. A will get the m and b will get the m. And similarly, if I've got a divided by b, or a over b, this whole thing to the m, then I can kind of again distribute so that a to the m over b to the m is what this will simplify to. Okay, so let's talk about these problems here. So number one, I've got 25 to the 3/5 times 25 to the 7/5. I see that they're the same base, 25. So what I can do is use my properties. This one is going to be a product of powers because it's got the same base in both. I'm multiplying, so I'm going to add those exponents together. So 25 to the 3/5 times 25 to the 7/5, this will be 25 to the 3/5 plus 7/5, which is 25 to the 3 plus 7 is 10/5, otherwise known as 10 over 5 is 2, 25 squared. And 25 squared is 625. Next one, 8 to the 1/3 over 8 to the 2/3. Just like I multiplied these together and really added their powers, here I'm dividing, so I'm going to subtract. This is going to be 8 to the 1/3 minus 2/3. So this is 8 to the negative 1/3. Another way to write this is 1 over 8 to the positive 1/3. And the cube root of 8 is 2. 2 times 2 is 4. 4 times another 2 is 8. So this will be 1/2. Okay, let's do something that's a little bit harder. Now I've got y to the 4/3 over 16, y to the 2/3, and this whole thing to the 3/2. So you could do this in a couple of different ways. The first thing I'm going to do is recognize that I've got a y on the top and a y on the bottom. So let's take care of that part first. Ignoring everything else, I see that this is division, so I would subtract these powers. This would be y to the 4/3 minus 2/3. And I'll still have 16 on the bottom. And this whole thing will still be brought to the power of 3/2. Okay, 4/3 minus 2/3, that is going to be 2/3, because 4 minus 2. So y to the 2/3 over 16 to the 3/2. And now, this outer power, what I'm going to do is kind of distribute it to everything on the top and everything on the bottom here. So this will be y to the 2/3, this whole thing to the 3/2, and 16 to the 3/2. Power to a power, so I'm going to multiply these together. This is y to the 2 times 3 is 6. 3 times 2 is 6, so y to the 6 over 6. And this will still be 16 to the 3/2. And finally, 6 over 6 is 1, so that's just y to the first power, or just y over 16 to the 3/2. This will be 64. All right, what about over here? I've got 27 x to the 3/4 and this whole thing to the 2/3. All right, let's begin by kind of distributing this outer power. That's going to go to everything. So 27 to the 2/3 times x to the 3/4 to the 2/3. So 27 to the 2/3, I'll leave that alone for now, times x to the 3/4 to the 2/3. So I'm going to multiply these together. 3 times 2 is 6 over 4 times 3 is 12. (27) to the 2 over 3, that's going to be 9. And then x to the 6 over 12, I can write that as x to the 1/2. Another way to have written this is 9 times the square root of x, since the square root of x is the same as x to the 1/2. Speaking of, let's talk about how we might simplify this with radicals. So this list of properties will be good for nth roots where a is greater than 0 and b is greater than 0. I've got the product of roots and the quotient of roots. Let's say I've got the nth root of a times b. Well, I can break that up and give each of these that radical. So nth root of a times the nth root of b. Where that might be helpful is, let's say I've got the cube root of 16 and I want to simplify this a little bit. Well, 16 I can break up into 8 times 2. So the cube root of 8 times the cube root of 2. And the reason I might select to do so is because I can actually take the cube root of 8. So that's going to be 2, leaving 2 cubed root of 2. in the quotient of roots, this is the nth root of a over b. I can again say the nth root of a over the nth root of b. Where that might be helpful is, let's say I've got the square root of 25 over 16. Well, I can break that up. Instead of trying to figure out the square root of this fraction, I can say the square root of 25 over the square root of 16. Square root of 25 is 5 over square root of 16 is 4. Let's look at some examples of these. Number 5, we've got the cube root of 256 x to the third y to the 7th. Okay, so 256. If I break that up, that is the same as 2 to the 8th power. So 2 times itself, a total of 8 2's, okay, multiplied together. So this is the same as the cube root of 2 to the 8th power, x to the third power, y to the 7th power. Now I'm going to break that up a little bit. And this will be the cube root of, watch what I'll do here, 2 to the 8th. I'm going to break that up to 2 to the 6th times 2 to the 2nd. So 6 and 2 together would make 8. So 2 to the 8th here, and I'll have another cube root. I'm going to multiply these together, where this will be 2 to the 2nd power. X to the third, I'll leave as is, and y to the 7th, I'll say that this is y to the 6th, and I'll have an extra y to the first, or just y over here. Now, why might I do that? Well, notice that this is the cubed root. Okay, the cubed root, oh, this should be a 6 here, not an 8. And that each of these exponents, 6, 3, and 6, these are all divisible by this 3, the cubed root, the nth root. So what I can actually do here is say 6 divided by 3 is 2. So this is 2 to the 2nd power. X to the third, 3 divided by 3 is 1. X to the 1st power. Y to the 6 divided by 3 is 2. Y to the 2nd power. And I'll still have over here hanging out the cube root of 2 squared and y to the 1st power. Well, this is 4x y squared times the cube root of 4y. So breaking this up right here was kind of the key spot. Breaking this up so that everything I've got left on the left one here, I could actually take the cube root of, and leftovers, okay, we're kind of over here. So that way I could take the cube root of everything, find this, and then show what was left over. All right, for the next one, I've got the 4th root of 81 over x. 81 over x. So I can take the 4th root of 81 over the 4th root of x. Okay, what is 81? I break that down into primes. I've got, this is 3 to the 4th power. So 3 times 3 times 3 times 3. So this is really like the 4th root of 3 to the 4th power over the 4th root of x. All right, so this will be 3, okay, 3 to the 4th root, so I'll say 3 to the 3rd root or 3 cubed to the 4th root, times I've got 1 left over. So the 4th root of another 3 here, over the 4th root of x still. Or no, sorry, this is actually just going to 4 divided by 4 is 1. So this will just be 3. So 3 over the 4th root of x. And what I'm thinking of here is I want to rationalize this. And so I've got the 4th root of x. What I would need are 3 more of these 4th root of x's so that there are 4 of them in total. So what I'll do to rationalize this, I'm going to multiply by the 4th root of x to the 3rd on the top and the bottom. Now this is just a fancy way of saying I'm multiplying by 1, because 4th root of x cubed over 4th root of x cubed, same thing, top and bottom, that's going to make 1. So this is really just changing the changing the way that this looks without really changing the value of what I've got here. So this will be 3 times the 4th root of x to the 3rd over the 4th root of x to the 4th now on the bottom. And finally, 3 times the 4th root of x to the 3rd over x.